What we'll do now then is run through an example of a two-way repeated measures ANOVA. So in ANOVA, when you've got repeated measures, it's the same as independent designs in that you can use more than one independent variable. You could use 2 or 3, more than that if you wanted to, but it's usually best to keep things fairly simple. So we'll run through an example of a two-way repeated measures ANOVA. So imagine you've got the following research scenario. This time, researchers were interested in the effect of alcohol and tiredness on reaction times. So to test this, the participants took part in a virtual reality driving test where they were required to react to road dangers. And in this design, participants took part in all conditions. So there was 6, if you like, conditions that they took part in, depending on whether they had no alcohol, 1 pint of strong lager, or 2 pints of strong lager, and also depended on whether they'd had a full night's sleep or whether they were somehow sleep deprived, they'd had a disturbed night of sleep. So although you've got, if you like, 6 conditions in this design, in a two-way ANOVA, what you can do is split this into the 2 independent variables. So now we've got alcohol with 3 conditions and sleep with 2 conditions. And we do this so that we can have a look at the effects of these independent variables on their own and also any possible interactions between the 2 variables, as with independent ANOVA. We've got one dependent variable still, which is reaction times. So what we'll do is run a two-way repeated measures ANOVA on this data. So I've got this data now in an SPSS file, and I'll just run through what we've got here. So we've got 6 columns representing each of those subcategories that we saw before. If I click on variable view, I'll make it a bit simpler. The first column then represents the category when people had no alcohol and no sleep, or a lack of sleep. The second column was no alcohol and sleep. The third was when they had 1 pint of alcohol and sleep and no sleep. The fourth was 1 pint plus sleep, and then the fifth, 2 pints with no sleep, and the final one, 2 pints with sleep. Now, in a two-way repeated measures ANOVA, you just need to pay extra attention to the entering of these variables into the ANOVA model. We'll demonstrate that now. Right, in Analyze, we'll go back to General Linear Model and Repeated Measures. And we'll get this box up again. And now what we need to do is define 2 factors that represent the independent variables. What I'll do is define alcohol first, and that had 3 levels or conditions. We'll add that, and then add sleep, and that had 2 levels, and then we'll click on define. And what you need to do here is just pay close attention to these numbers here. What SPSS has done is it's ordered, if you like, alcohol first and sleep second. And if you go down this column of numbers here, this 1 here represents the first condition of alcohol, so that was no alcohol. And then these 2 represent some alcohol, and then these 2 represent the 2 pints of alcohol. And then the second column of numbers here is to do with sleep. So for this group, 1 would indicate that they had no sleep, 2 would indicate that they had sleep. And I've got these in the order now that they need to go into here. So the first group was no alcohol with no sleep. So we know from these numbers, 1 for no alcohol and 1 for no sleep, that this needs to go into this first row here. The second row, you'll see the numbers are now for no alcohol and this time sleep. So we can move this one, no alcohol plus sleep, into this box. And then the next row is 1 pint of alcohol, represented by 2, and no sleep, represented by 1. So we can put that in there. And then these are in the correct order, so I'll just add these into there. But just pay attention with your own data. All right, so then we'll select some options. We'll select plots first. This time we need to add alcohol in the horizontal axis and sleep in the separate lines. Now we've got two variables, we can have a look at if there's any interaction. We'll click on Add for that and click on Continue. And then select Options and we'll select Descriptive Statistics and Estimates of Effect Size. And we'll also select the mean scores for alcohol, sleep, and also the interaction alcohol by sleep. What we'll do is also select compare main effects and get up some post hoc tests as well. And we'll select SIDAC for this. And click on Continue. And we'll forget about the contrasts option for this one. We'll just stick to post hoc tests for this. But contrasts, like we said for the last example, contrasts are also available for two-way repeated measures ANOVA. So we'll click on OK and get up the output. And then like with the one-way repeated measures ANOVA, you get a lot of output out here. So we'll just focus on what you really need to know. First of all, just look at the descriptive statistics. Have a look at what might be going on. Remember, these are mean reaction times. So the larger the mean, the slower the reaction time. And we can just eyeball that data and see that alcohol seems to be having some kind of effect on reaction time. But particularly for this group here, when they had 2 pints with no sleep, the mean score here was very high. So we can get into the output now then. Now, this time, when we look at the multi-choice test, there's two things to note. First of all, we've got two p-values, and this represents the p-value for alcohol and also the p-value representing the interaction effect. But there's no p-value reported for sleep. Now, this is because when you've only got two conditions in an independent variable, you don't need to test for sphericity. It's only when you've got more than two conditions that this is the case. But what this shows is that we've got significant p-values representing that we've violated the assumption of sphericity here. So we'll need to use the corrected test statistics for this example. You'll see then that the within subjects effects table now gets slightly more complicated in that we've got two main effects and one interaction effect. We've got the main effect of alcohol here. We've got the main effect of sleep, and we've also got the interaction effect here. And it also reports the error for each of these effects. And really what you need from that is one of the degrees of freedom. So we'll go through that in a minute. Focus on alcohol first. The main effect of alcohol, we'll use now the greenhouse Geyser statistics. And we first of all need to just pick out the degrees of freedom. So the first degree of freedom using the corrected statistics is 1.16. Then you want the error degrees of freedom, which is 22.06. And the F statistic now will be this one, 51.38, P of less than 0.001, and eta squared of 0.730. Now, unlike the previous example, these are now partial eta squared because you're looking at separate effects in the model. So we've got a main effect of alcohol, which is significant, and then we'll move on to the sleep main effect now. Again, we can just pick out the relevant bits of data. The degrees of freedom now is 1 and 19. You can see that I've used the sphericity assumed degrees of freedom here. Now you can look at the greenhouse Geyser statistics and see that they're exactly the same. It hasn't adjusted the degrees of freedom. And this is because, as I said, you don't need to worry about sphericity when you've just got two conditions in an independent variable. So here we can report 1, 19. The F statistic is 88.61. The p-value is less than 0.001. And the eta squared, or partial eta squared, is 0.82. And now we'll just move on finally to the interaction. You can see there's also a significant interaction effect here. So the degrees of freedom now will be 1.15, the second degree of freedom 21.91, the F statistic 23.36, a P of less than 0.001, and partial eta squared of 0.55. So what we'll do now is just explore this a little bit further. What does this all mean? So we can look at the alcohol effects. Got the mean scores here for each group and the post hoc tests. So group 1 was the no alcohol, group 2 was when they had 1 pint, and group 3 was when they had 2 pints. You can look at the mean scores and see here that there does seem to be a difference in that when they had 1 pint, their reaction times were slower, and then particularly when they had 3 pints, their reaction times were very slow. And we can look at the post hoc tests now and compare group 1 or condition 1 with condition 2, which was significant at 0.032. Compare condition 1 with condition 3, which was also significant, and condition 2 with condition 3, which was also significant. So all groups differing significantly from each other here. So we can interpret from that that higher doses of alcohol were having more of an impact upon reaction times. You'll see that it also reports post hoc tests for sleep. Now, we don't really need to use these because we know from the main effect of sleep that this is significant because there's only 2 conditions. So there's no other way that they could differ other than sleep group 1 being significantly different to sleep condition 2. So we'll just focus on the mean scores. We can see that when participants had sleep deprivation, their mean reaction time was slower than when they had a full night's sleep. And quite a substantial difference between those two as well. Now, finally, we'll just look at the interaction. So the interaction effect was significant. And when you look at the plot, you can see that the most pronounced effect here is for this alcohol group 3, which was when they had 2 pints. Now, when they had a full night's sleep, it was impairing their reaction time, but very slightly compared to when they had 1 pint. There wasn't much difference. But it was when they had sleep deprivation in combination with 2 pints that this was when it was really impairing their reaction times. And you can see it jumps up very substantially here. You could use, if you wanted to, simple effects analysis on this, as with a 2-way independent ANOVA. And if you wanted to do that, go into the Andy Field book and have a look. What you could do with simple effects then is to see whether this difference here is significant. And it looks like it would be, but that would just give you a statistically significant p-value to determine that. We won't do that for this practical. We'll just interpret this interaction more generally. And I've got an example here of how you would write this up. You can see that when you've got 2 variables, the write-up becomes more complex because you need to pick apart the main effects and the interaction effects. But you could write it up something like this. I won't go through the whole thing. You can read that in your own time. Just make sure that you've reported the statistics for the main effects and interaction effects, along with any post hoc tests that you've done and any simple effects if you've done those as well. You also want to indicate, if you're writing this up and you are using the corrected statistics, in this case the greenhouse gas statistics, you'd want to indicate that you'd used those corrected statistics rather than the sphericity assumed statistics. You also might want to, if you're looking at 2-way ANOVA, present the mean scores and probably the standard deviations in a table as well. Otherwise, if you try and write them all out, it can get a little bit messy. So if you present them in a table or in a graph, then you've got that information there and you don't need to really repeat that information in the write-up. So that's it then for a 2-way repeated measures ANOVA. Next week, we'll run through some non-parametric tests, and that will be your final practical. So we'll run through the standard non-parametric tests that you'd use when your data isn't suitable for a parametric test.